Hello students, I think last class we have learned about ionic bond or electrovalent bond through this atomic orbit structure. I think we have seen an example of sodium chloride and calcium oxide. Now today's class we will see that is ionic bond continuation of one more example, that is magnesium chloride MgCl2. So we are going to follow only atomic orbit structure this year. The next year we will be following the electron dot structure. So electron dot structure is given here. So if you are getting confused with this, just you can need not follow that thing. So you follow only this atomic orbit structure. So now we'll see atomic orbit structure of MgCl2. See, magnesium atomic number is 12. So 12 proton, 12 neutron. Then you fill the electrons in the K shell 2, L shell is 8 and M shell is 2 electrons. Now we will go for chlorine then. So one magnesium atom, but see the previous cases chlorine one atom we have drawn for sodium chloride. For calcium oxide we have seen only one atom of oxygen, one atom of calcium, but here this is different, which we have the formula of MgCl2. So one magnesium atom and two chlorine atoms you are going to draw. Two chlorine atoms. So now what I am going to do here is the chlorine atomic number is 17. So two chlorine atoms you can draw this way, or you can put the magnesium atom in the center. At the sides you can draw chlorine atom. You can follow your textbook pattern also, the diagram for exam. So I think some textbooks will have magnesium here like this. At the sides you will have two chlorine atom, or magnesium in the center, the either sides of this magnesium atom as chlorine. So that way also you can draw. So no problem. Now chlorine 17 atomic number, and you know the neutron is 35 minus 18 is minus 17 is 18 neutron. So 35 is the mass number. So when you subtract 35, that is 17, you will get 18 neutrons. So same way for another chlorine atom also, 17 proton, 18 neutrons. Now you start filling the electrons in the K shell as 2 electrons, L shell as 8 electrons and M shell has 7 electrons. The same way here also, K 2, L 8, M 7 electrons. So you are drawing two chlorine atom structure, because see here this case ionic bond means, once again you recollect the thing, that is transfer of electron, complete transfer of electron from a metal to a non-metal. See, from a metal magnesium atom to a chlorine metal. See, in magnesium cases I have 2 electron in the last shell, two electron in the last shell. So if I give one, because one chlorine atom will need 1 electron to complete the last shell, that is 8, to get 8. So chlorine is in need of 1 electron to get 8 in the outermost shell, and magnesium has to lose 2 electrons. So one chlorine atom, each chlorine atom will get 1 electron from magnesium. See, 1 electron from magnesium to one chlorine, the other electron from magnesium atom to the other chlorine. So 2 electron has been transferred there. So if it transfer 2 electron only, magnesium also becomes stable and this chlorine also becomes stable. Now we have to see the nearest noble gas for this magnesium atom is neon, and for chlorine is the nearest noble gas is argon. So ionic bond means a transfer of electron from the metal to a non-metal atom there, complete transfer of electron to attain a stable inert gas configuration. So magnesium is attaining neon electronic configuration and chlorine is attaining the argon electronic configuration. So now the electronic configuration changes there. Now see, after transferring the electrons, see magnesium only 2 shells are the K and L shell, because 2 electrons I have given to chlorine there. So when you look at the chlorine atom, you check the count number of atoms, here 4 and here only 3 is given, 1 more electron has been gained. The gain of electron has not been 4 electron 4. See here 4 4. Last shell you see 4 electron, here also 4. Same way here 1 2 3 4 5 6 7 8 electron. So 1 electron it has gained. Whereas here you have only 7 electrons there. So 1 electron has been gained, and each chlorine atom is getting 1 electron from the magnesium, one single magnesium atom. So after giving 2 electrons, the magnesium atom becomes magnesium ion. So losing 2 electron, put a square bracket or box bracket and write it as 2 plus. Now in the case of chlorine atom, 1 electron it has been gained, so 1 minus. The same way here also put a box bracket or a square bracket and write it as 1 minus. So you have to draw 2 chlorine atoms. See, in case if you are drawing 1 chlorine atom here, you have to put 2 minus. Instead of drawing 2 structures here, 2 minus you can write. Or if you want to, you are getting confused, you can follow this one, 2 chlorine atoms. It's better you draw 2 chlorine atoms, and each chlorine atom you should write 1 minus, not 2 minus. You all, I think you have followed the thing. I think you have understood that. Now once again we'll see 2 electron it is transferring from the magnesium 1 to each chlorine atom, and now it becomes Mg2 plus Cl1 minus, 2Cl minus. Now see, the electronic configuration has changed for magnesium atom to magnesium ion as 28 and for chlorine atom 288. See, this is the electron dot structure. So electron dot structure means we are not drawing the shells. Only the electron representation in the outermost shell you are representing it as. So magnesium 2 here and a chlorine 7. Magnesium atom, chlorine atom. Now see, this magnesium has lost 2 electrons, so 2 plus, and chlorine is gaining. See, the blue color electron has gone to chlorine there, and from here to another chlorine. So it becomes minus chloride ions. It's no more chlorine atom. So this is how you have to draw the structure of magnesium chloride. It's a very important structure. So practice and see how to draw this magnesium chloride. Next we'll see the covalent bond, that is covalent molecule. So covalent bond means I have explained about, that is sharing of electron between the two non-metals, So you're going to share from one non-metal to the other non-metal the electrons there to attain the stable inert gas configuration. So now we'll see a simple example of hydrogen. So far we have seen it's a complete transfer of electron, but this is sharing of electrons. Now in the hydrogen case, see, atomic orbit structure of hydrogen. See, I'm going to draw 2 hydrogen atoms. One hydrogen here, the other hydrogen. See, of different thing, 1 electron. Now what we are going to do, see, this hydrogen has to become stable, means it has to get 1 electron. The same way the other hydrogen atom has to get 1, means it has to get 1 more electron there, stable. So it is getting the duplet rule there, it is obeying that, and getting the helium gas, noble gas configuration. So now it becomes as, it is sharing. So both are in need of electrons. So this is also in need of 1 electron, and the other hydrogen also is in need of 1. So we are going to draw the orbital as one overlapping the other one. See, one is on the other thing. It's overlapping there. Now you have to draw those 2 electrons in common for both the hydrogen atom. So this 2 electrons should be common for both the hydrogen atoms. I think you have understood. So it should overlap, that shell should overlap the thing and draw and show sharing. You are showing that a shared pair of electrons. So spelling is wrong here, not electrons, electrons. I should not come there. So the nearest noble gas for hydrogen is helium. So this is the atomic orbit structure of hydrogen, where you are showing the sharing of electrons. So if you go for electron dot structure, see, 1 hydrogen atom, you are not showing the shell structure here. The same way 1 more. So it is going to pair, and you can just represent the 2 electrons are common for this one. So this is a hydrogen molecule. So this is that's why we say the other name for covalent bonding as molecular bonding. So this we call it as a molecule. So single atom, 2 atoms combined to form a molecule. This is a very simple example. See, a pair of electron is shared between the 2 hydrogen atoms. So this is a pair of electron. Pair of electron means 2 electrons are there, which is shared between 2 hydrogen atoms. Now we'll see the one more example of nitrogen. Nitrogen N2, you know the structure. See, each nitrogen atom has 7 atomic number there. So 7 electron you have to represent. So in the K shell you are going to represent 2. The remaining 5 electrons like this. See, when you draw 5 electron, 2 electrons normally we draw. In pairs we will draw. So 1 electron alone will be left as alone. That is how we draw the structure for nitrogen. But here what we have done here is, we have written 2 electrons in pairs. So this you can pair it, or just you can write like this also. So pair of electron, the remaining 3 electrons should face the other nitrogen atom. Same way this also, another nitrogen atom when you are drawing. Say electronic configuration 2 5. Here 2 electron in the K shell, and in the L shell you have 5 electrons. See 2 electrons, you can draw it as a paired electrons. The remaining 3 which is left here, you can just leave it here like this. Either you can write 3 electrons this side or the other side, which is facing towards each other. So one nitrogen atom, 3 electrons should face the other nitrogen atom. Like this you have to draw. Now what happens? This is actually not overlapping. So when you are drawing, you just overlap the other one. The last shell is not overlapped here, but you overlap the thing and draw. See 2 electron in the K shell, 2 electron in the L shell, but the remaining 3 electrons I have drawn inward, showing that it is forming, it has 3 pairs of electron. 3 pairs means totally you have 6 electron. 6 electron is thing which you are saying it as in the form of 3 pairs of electrons. So the triple bond is formed there. So if you want to form a triple bond here, 3 pairs of electron is needed. See, to form one single bond, a pair of electron is needed. That is what has happened in hydrogen case. Only one pair was there. But here it is 3 pairs of electrons where triple bond is formed there. See, from a nitrogen atom we are getting, because why we are sharing like that, why we are in need of this 3 electrons, why we have drawn like this means, see, actually for nitrogen to make it as a stable one, see 5 electrons are there, 3 more electron it is in need. So that's why we are drawing 3 electrons separately, which is facing to the other nitrogen atom. See, the other nitrogen atom also, it is in need of 3 electrons. So both are in badly need of 3 electrons. So what we will do, we will share the 6 electrons between the 2 nitrogen atom. Now it becomes after sharing, it becomes a molecule of nitrogen. So this is the atomic orbit structure of nitrogen. I hope you understood the thing. See, because we are in need of 3 more electrons. So the 3 electron you should draw it facing to the each nitrogen atom. Here the diagram is given differently. This 3 electrons should face here, and while drawing this structure it should overlap and show that 3 like hydrogen, 3 pairs of electrons are in common. Like that you have to draw. I think in the textbook it is given clearly. You can follow that diagram. This is electron dot structure. See here also what they have done. One pair of, see outermost shell we have 5 electron. That 5 electron they have represented like this. See 5 electron, 1, 2, 3, 4, 5. 1 electron alone in pair it should be there. The remaining 3 electron you pull inward. See like this it forms 3 electrons, because it is in need of 6. When you draw the structure, overlapping structure like this, but this is actually electron dot structure. Now this bracket and all is not required. Just some textbooks they will give the thing. No need to worry about this bracket and all here. So bracket is only for ionic bonding, that is electrovalent bond. See 1 pair of electron, and here 3 pairs of electrons are there. So triple bond is formed. See one single bond has, to form a bond, 1 electron pair is required. The same way the other bond, if it wants to form 1 electron pair here. So totally you have 3 electron pairs to form, pair of electrons to form 3 single covalent bonds. So if they ask you how many lone pairs are there in nitrogen molecule, means 1 lone pair. Here see, nitrogen atom is 1 pair. Nitrogen molecule, if they say 2 lone pairs here. See each nitrogen atom is having 1 lone pair. So you should be very careful in answering this question. Nitrogen atom 1 lone pair. Nitrogen molecule means you have 2 lone pairs here. Nitrogen molecule. So triple covalent bond is formed. The nearest noble gas for this nitrogen is neon. I hope you understood this one. Next we will go for the oxygen atom. See oxygen atom, you know that its atomic number is 8. So if you want to write proton neutron here, or if you want to write the symbol also, is okay, fine. So symbol they have written K shell 2 electron, 2 oxygen atom I have to draw. See O2, so 2 oxygen atoms I am drawing. So K shell 2, remaining 6 electrons in the L shell. The same way 2. So in pairs you have to draw. So 6 electron is paired. See, when you look at the first oxygen atom and the second oxygen atom, both are in need of 2 electrons to become a stable one. So they are in shortage of 2 electrons. So what am I going to do is, so the last 2 electron in that 6 electron, take 2 electrons and put it inward, draw like this. The same way the other 2 electron from the other oxygen atom, because totally we have 6 electron in the oxygen atom, the last shell. Here also 6. So 2 electrons I am drawing it in common here. The same way the other 2 electron from other oxygen atom, draw it in common. It is sharing there. Both the oxygen atom is sharing the electrons there. So it should overlap, and in the center it should be common, this 4 electron for both the oxygen atoms. You count and see 1, 2, 3, 4, 5, 6, 7, 8 for this oxygen. Same way for the other oxygen, you have to take into account of all the electron which is present in the center, sharing. 1, 2, 3, 4, 5, 6, 7, 8. So this atom also stay with this also. Now it becomes a oxygen molecule. So it is formed by the atom share electron to make each one more stable. So the nearest noble gas is neon. So if you are representing with the electron dot structure, so I am going to represent 6 electron for each oxygen atom. Here also 6. So now what happens? 2 electron is facing inward here. In that case, see this reversible arrow and all you need not consider, just you write it there. So what happens here? There in nitrogen case, triple bond is formed. 3 pairs of electron is forming the 3 single covalent bonds. But here 2 electron pairs are required. So I have drawn double bond here, that is 2 electron. 1 electron pair for this bond, and another electron pair for the second. So 2 double bond, we call this as double bond. So 2 pairs of electron or 4 electrons are involved in the bond formation. So why we call this lone pair, L-O-N-E, lone pair? This is bond pair. So what's the difference between lone? I'm saying it as lone pair. Even for nitrogen, I said each nitrogen atom 1 electron pair, and 2 nitrogen molecule means 2 electron pairs, I said. But for oxygen, we have, see this 2 electron, this electron for this oxygen, the other 2 electron here. So totally here 4 electrons or 2 pairs of electron. Here also 4 electron, 2 pairs of electrons. So what happens here? They are not involved in the bond formation. So that we call it as lone pair. The electron which is not involved in the bond formation, we call it as, see this electron pair, the other electron pair are not involved in the bond formation. Only the electron which is in the center is involved in bond pair. So this we call it as bond pair, and which is not involved in the bond pair, we call it as lone pair. So these electrons are lone pair. This is also lone pair. In the center which is involved in the bond formation is called bond pair. So for oxygen atom, a single atom has 2 lone pairs of electron or 4 electron. If it is oxygen molecule, we have 4 pairs of electrons. See here, this is also considered. Single atom means 2 lone pairs. If it is a molecule means 4 lone pairs for oxygen. Whereas nitrogen, we said 1 lone pair for 1 nitrogen atom. Nitrogen molecule means 4. One more, so 2 lone pairs we said. So here it is 4 lone pairs for oxygen molecule. So pair means 2 electrons, that you should have it in mind. So this is the covalent bond structure for oxygen. So one more example we'll see for chlorine. See chlorine atomic number 17. So we have represented the symbol like this. See, we have not drawn the square bracket for hydrogen, nitrogen, oxygen, even for chlorine, because we are talking about covalent bond. So square bracket is not required for this, or plus or minus is not required, because we are not completely transferring like ionic bond. So this is entirely different bond. So either by complete transfer or sharing, it becomes a stable one. So somehow we are doing that to make an atom stable. So now chlorine, 2 chlorine atoms I have to draw. See K shell 2, L shell 8 and M shell is 7 electron. The same way here also K shell 2, L shell 8, M shell is 7 electron. So now both the chlorine atoms, they are in need of 1 electron to make it as a stable one. So last shell it should contain 8. So one more electron, this chlorine is needed. The other chlorine atom also is in need of 1 electron. So now what these are unstable ones. I am making that to stable by getting the nearest noble gas for chlorine is argon. So what I am going to do, 287 is going to change it as 288 electronic configuration. There will be a change in electronic configuration, of course. So now this last electron of this chlorine and this chlorine, I am going to draw it in common here. See here, this place is the common. It is, you have to overlap that structure and show. So in a textbook it's given correctly that method you can follow. See 2 electron. See last shell I should have a 7 electron. See 1, 2, 3, 4, 5, 6. The 7th one I have drawn here. The same way here also 6 electrons and 1 electron here. So if I count for this electron, I should consider 7, 8 for this. For this chlorine atom, 7, 8. So these 2 electrons are in common for both the chlorine atoms. So if it shares both the electrons there, so it is going to form a stable chlorine molecule. Same way it is represented in electron dot structure. See here the last shell alone electrons we have put. Electron dot structure means last shell. See this is in 1 electron, this is going to share. So this is how you have to draw the structure here also. So it is shown here in electron dot structure. See when I count here 1, 2, 3, 4, 5, 6, 7, 8 for this chlorine. When you count for this chlorine 1, 2, 3, 4, 5, 6, 7, 8. So this 2 is sharing the electrons there and it forms. So how many electron pairs are involved in sharing? 1 electron pair, that is 2 electron forms a bond, single bond. See for hydrogen, chlorine, single bond, covalent bond. But for nitrogen is 3 single, triple covalent bond. Triple bond we say, or 3 single covalent bonds. For oxygen, 2 single covalent bonds, that is double bond. That is what is involved here. So we have seen atoms so far, hydrogen, nitrogen, oxygen, chlorine, of homo atoms. It is homo, same atom, but different atoms we will see in next class. And the assignment for you is in page number 77, additional questions from 9 to 12. Mark the answers under. And what all structure we have taught today, that is magnesium chloride, hydrogen, that is covalent. These are all examples of covalent, and magnesium chloride alone ion. So you draw the structure, practice that one. Thank you, students.